Who wants to solve it? Rosa? Do you want to try? Did you try it on your notes?
Yeah, but I'm not like finished yet.
Okay. Maybe you want to come and do it here and finish it again. Let's calculate EX squared first. Maybe you want to write it with dx. Why don't you write them all under one denominator?
Yeah.
As you proceed, your font size decreases. So towards the end, you have like font size 1. Why do you multiply? This is EX squared. That's okay.
Yeah, it's.
Can you simplify it a bit? It's B squared plus AB plus A squared. Put parentheses around B minus A as well. In the numerator, in the top, put parentheses between B minus A. Yeah? Okay? So this is equal to, the result is equal to B squared plus AB divided by 3. And already we know what's EX, right?
Yeah.
So sigma squared is equal to, so this is B plus 1 squared divided by 8. B squared plus A squared plus 2AB. Yes, you have to write this one. Now,
You see it?
yeah, they have to say yes. Write down sigma squared is equal to just subtract 2 terms. Square plus AB. No. B squared plus AB plus A squared divided by 3 minus B squared plus 2AB plus A squared divided by 4. And I think that people can just leave it like that. That's okay. And I think that people can do it. Just write is equal to B minus A squared divided by 12. Thank you. Actually, we get something like b squared minus 2ab plus a squared divided by 12, which is b minus a squared divided by 12. Thank you. Now, the next distribution, which we will use it quite a lot, is in computer science, in electrical, and
In this also, it will also be a minus b squared divided by 12.
it should be a minus b.
It could be also.
Yes, but we understand that minus to power 2
Yeah.
is
Plus.
plus. In other words, b minus a squared is equal to a minus b squared. You ever seen?
Yeah,
Good. As we agree, that's good. Now, in electrical and electronic engineering, in telecommunication, in I don't know, space engineering, in computer science, in many fields of engineering, physics, and science, there is one distribution which we love it. It's a very special type of distribution. It's a very realistic type of distribution, and it is called normal distribution, also known as Gaussian distribution. And we want to talk about this one. We want to talk about its properties and why it is so cool. So, normal distribution, also known as Gaussian distribution. This distribution looks like this. It's like a hat distribution. It has lots of important properties. One of the most important thing about this distribution is that mathematicians have done lots of work on this distribution. So whatever you can think of it, they have done it. So it means that it's a well-studied type of distribution. We know what is the area underneath this curve at any point. If you put out a point, and we know that what is the area less than that point or more than that point. Because it is a continuous distribution, for example, at point x0, the area underneath is 0, because area underneath the curve is 0. But we know that what is the area less than x0 or area more than x0. It has also a couple of other important properties. One of these properties is that if you are familiar a little bit with, let's say, signal processing, we know that when we have a signal, we can transform this signal into something which is called frequency domain, right? So we can have time domain and frequency domain. And one of the cool things is that if this signal, or if this distribution, if this function is in time domain, and you change its domain to the frequency domain, you still get a Gaussian, a normal distribution. So it doesn't change its nature. It changes the magnitude, the values maybe, but it is still Gaussian. Another important thing, which is very useful in communication, is a theorem which is called central limit theorem. And central limit theorem, which is also very famous in probability, tells us this. If we have infinity many random variables, okay, we have infinity many random variables, and each of these random variables have different type of distributions, okay? So one of them has uniform distribution, one of them has binomial distribution, maybe all of them have uniform distribution, doesn't matter. But if we add all these random variables, in other words, if we add all these random variables with different distributions, we will get normal distribution. It's called central limit theorem. So adding infinity many distributions will result into the normal distribution, into the Gaussian distribution. And this is a very important property. Of course, you don't have infinity many, so we approximate, and we say that if you have, let's say, hundreds, thousands of them, that's enough for us to go and approximate it by using Gaussian distribution. And why do you want to do this approximation? Because, as I said, mathematician has attacked to this distribution very well, and we know everything about this type of distribution. And this is one of the type of distribution that in order to express it, you need to know only two things. One of them is you need to know its mean, the other one is you need to know its variance or standard deviation. If you know it, you can draw this function properly. You do not need to know any extra information. Okay? So that's why it's a very, very important type of distribution. We will solve lots of examples about that one, and if you may remember from maybe previous courses, we usually have a table of normal distribution, which you have to look at the table in order to calculate the area underneath the curve. In your homework, I will put the table in the module. In your homework, you can use that one that is available in module, or you can use internet, or you can use your computer to calculate it. In the exam, I will provide you a table if it is required. Okay? So this is the story about this distribution and why it is important, but let's go over it and talk a little bit about this distribution. Many physical phenomena are described very well by a normal distribution, such as human height, for instance, such as measuring errors in an exam. Or many things that we have in our daily life are actually this type of distribution. And normal distribution is described only by two parameters, which are mean, mu, and STD, standard deviation, sigma. And we can define it in this form. The PDF of normal or Gaussian random variable x with mean, mu, and a standard deviation sigma is n of x, mu and sigma, it is 1 over a square root of 2 pi sigma e to power minus x minus mu s squared divided by 2 sigma squared. Some books, they say that, normal distribution is expressed by mu and variance, and they reform this formula as you can see in the denominator of the exponential, we already have the variance. But variance or standard deviation, they are the same, but only one of them is the square root of the other one, right?
some notes. X minus mu squared, which we have it in the numerator of the exponential, is s squared distance from the mean and what will happen? Look, x minus mu is this. This is my mu. This is my mu. And x is a value like here. So x minus mu shows this distance. Okay? X minus mu shows distance. And in the numerator of exponential, I have this distance squared. So can you tell me that what will happen if I go further from mu?
Decreasing.
Huh?
Decreasing.
Decreasing. Decreasing what?
It's values.
As we are going further from mean, Ozan is right, but as we are going further from mean, we are increasing the distance, which means we are increasing this value, which means this number will become bigger with a negative sign, so the results of exponential will decrease. That's why that, as you can see, the value starts to decrease as x goes further away from you, right? So hence, as x minus mu is increasing, then e to power minus x minus mu s squared divided 2 sigma squared decreases. Okay, now another question. And this decrease means that the value of our distribution decrease. What does it mean, the value of our distribution decrease? The probability will decrease. So the probability of its occurrence will decrease. Okay? So this is how you have to understand it. So what does sigma tell us? So x minus mu tells us that as it is increasing, the probability decreases. But what about sigma? What is the role of sigma? So we are decreasing. We agree that we are decreasing as x minus mu increases, right? How fast we are decreasing depends on sigma or sigma squared. As if sigma is bigger, we decrease faster. So sigma tells us how faster we are decreasing our value as we are going away from mean. We remember that we can have something like this. Yesterday we drew it, right? As sigma gets smaller and smaller, we know that this value, the peak value, will go higher because the area under this should be 1, but we are decreasing much faster. We are decreasing much faster. So we are decreasing much slower because it's in the denominator. If sigma is smaller, because if it gets smaller, these results will get bigger. So this value will be a negative but bigger. So we start to become, we have the bigger changes in here than in here. What is this term? Why do we need to have this term? If x is changing, does this value change? No, it is fixed. And it is actually basically a constant which makes sure that the area under this is equal to 1. The area under this is equal to 1. If two normal distributions have the same sigma but different mu's, then how do they look like? We have two normal distributions on. One of them, sigma is 1, mu is 1. The other one is sigma is 1, mu is 5. Thank you, Ozan. I ask Ozan. Yes, they do. So how do they look like?
They like shifted.
No, they look like the same, but they are shifted. So they look like the same, but they are shifted. I hope I can draw it the same. So this is like N1, which is mu1 sigma, and this is N2, which is mu2 sigma. So say they look the same, but they are shifted. They are translated version of each other. What about if their sigma are not the same, but their means are the same? They do not look like each other at all,
But they're in the same place.
but their maximum, their peak is happening at the same place, which is the mean. And it is like what we have in here. Now, the mode of density function is the x that has highest fx value. In general, if we have a distribution, then mode, the mode, what is mode?
The highest occurring.
The most frequent one is the one which makes the value of fx to be maximum. So in normal distribution, what can we say about mode? Thomas, what can we say about mode for normal distribution?
Equal to mu.
Yes. Mode and mean are the same. Mode and mean are the same. Do you have any question? Okay, if you have no question,
we have to solve some example to see how to revise how we were calculating the probability underneath this distribution. And then we do an example about a random process which has this type of distribution, and we see how we can handle it. But we will do it next week.